We all experience consciousness, that feeling of, well, being you, right? Your thoughts, perceptions, your whole subjective world. But what is it really? And maybe even harder, how does something so intangible arise from the physical stuff in our brain? That's the huge mystery we're diving into today. In neuroscience, they call it the hard problem. It's famous, isn't it? How do physical brain processes, neurons firing, give rise to subjective experience?
Exactly. It's not just about mapping what the brain does, but understanding how that creates the feeling, the qualia of being alive.
So today we're embarking on a pretty deep dive into this whole question. We're going to unpack a really fascinating collection of sources. We'll look at cutting-edge neuroscience, mapping brain activity linked to consciousness. Then we'll explore some more controversial theories, ideas that consciousness might exist outside the brain.
Right, the non-local ideas.
Exactly. And we'll even get into breakthroughs in building artificial brains using silicon and even living neurons.
Yeah, the AI angle is fascinating too.
Yeah. Our mission here is simple. Distill the key insights, the surprising facts, the really challenging questions from all these different angles. We want to help you become well-informed on this incredibly profound topic quickly and thoroughly. So let's get started. Okay, so our journey into consciousness really starts with this core tension, this big debate. Is consciousness actually generated by the brain? Or is the brain maybe just a receiver for something else? What's the sort of standard scientific take on this?
Well, the prevailing scientific view, the consensus, is definitely that consciousness emerges from physical brain processes. Now, we don't fully grasp how subjective experience arises. That's the hard problem you mentioned. But neuroscience largely operates on that assumption. The focus tends to be on identifying what we call neural correlates of consciousness, or NCCs for short.
HTCs,
Yeah. These are basically the specific brain networks, the activity patterns, the signatures that are consistently active and present when we are conscious. Even if we don't know the exact origin, they're seen as necessary correlates, like the brain's fingerprint of consciousness.
Okay, so what are the main theories trying to explain these NCCs?
There are a couple of really prominent ones. One is the global neuronal workspace theory, often called GWT or sometimes GNWT. This theory suggests consciousness arises when information, initially processed locally by specialized unconscious parts of the brain, gets broadcast.
Broadcast, like shared widely.
Exactly, broadcast across a central workspace in the brain. This makes that information globally available for flexible thinking, memory, planning, decision-making. And we often see some empirical support for this, things called ignition effects.
The ignition effect.
Yeah, they're like these nonlinear waves of activation that light up the prefrontal cortex, the PFC, the brain's executive control center, right when a stimulus crosses the threshold into awareness. So the key idea of GWT is that consciousness is about making critical information globally accessible within the brain, like a central stage.
Interesting. A central stage. What's the other main theory?
Then there's integrated information theory, or IIT. This was quite different, much more mathematical. IIT proposes that consciousness isn't just about information access, but about integration. It says consciousness can actually be quantified.
Quantified. How?
Using a measure called phi, represented by the Greek letter A. Phi measures the extent to which a system's cause-effect structure as a whole is more than the sum of its parts. Think of it like this. How interconnected and unified is a system, really? How much information is lost if you break it down? That irreducibility, that more than the sum, is phi.
Okay, so hi-fi means more integrated, potentially more conscious.
That's the core claim. What's powerful and maybe controversial about IIT is it suggests consciousness is a fundamental property of any system that's sufficiently integrated, not just biological brains. This kind of implies a form of panpsychism that consciousness could be much more widespread in the universe.
Wow.
And they're refining it. Recent versions, like IIT 4.0, tweak the mathematical definitions. Plus, tools inspired by IIT, like the Perturbational Complexity Index, PCI, are actually being used in clinical settings.
PCI, what for?
To gauge consciousness levels in patients who can't respond, like after a brain injury.
Yeah.
By perturbing the brain and measuring the complexity of the response, they get an index related to integrated information.
That is fascinating. So we've got GWT focusing on information broadcasts, especially to the front of the brain, and IIT focusing on mathematical integration, potentially anywhere. But science never stands still, right? Has anything come up recently that actually challenges these big theories?
Absolutely. There was a major study published not too long ago, large-scale, multinational, over 250 participants,
Right.
12 different labs involved.
Wow.
They were measuring brain activity while people consciously perceived images. And the results were, well, pretty surprising. They found that the strongest signatures of consciousness weren't actually in the frontal areas, like GWT would predict for that global workspace idea.
Really? Where were they then?
They were stronger in the posterior sensory cortex, the back of the brain, where sensory information first comes in. And interestingly, the data didn't really give strong support to IIT either, at least for ongoing conscious experiences. They didn't see the expected widespread network integration in those sensory areas.
So the back of the brain might be more critical for the actual experience of seeing something than the front parts involved in thinking about it.
That's what this study strongly suggests, yeah.
Uh,
It indicates the posterior cortex might be much more central to conscious perceptual experience than previously thought, which definitely poses a challenge to the assumptions in both GWT and IIT.
So just when we think we're getting a handle on it, new research throws another curveball. It really shows how complex this hard problem is. But, amidst all the scientific work focusing on the brain, there's that powerful counter-narrative we mentioned. The idea that consciousness isn't something the brain makes at all, but maybe something it tunes into. Can you tell us about Pim van Lommel's work here?
Right, Pim van Lommel. He's a Dutch cardiologist, and he's a key figure pushing this alternative view. His argument really gained traction from a landmark prospective study he published in The Lancet back in 2001.
The medical journal.
That's the one. It involved 344 cardiac arrest survivors. Now, about 18% of these people reported near-death experiences, NDEs. And critically, these experiences happened while they were clinically dead, meaning a flat EEG,
Right.
indicating no measurable electrical activity in the cortex, and other signs of ceased brain function.
Flat EEG. So clinically, no brain activity, but they remembered things.
They reported detailed, lucid conscious recollections during this period of presumed cortical inactivity. Van Lommel argues this fundamentally undermines the idea that consciousness is solely produced by brain activity. His proposal is that the brain acts more like a transceiver. It facilitates consciousness, it allows us to experience it, but it doesn't generate it.
A transceiver, like a radio picking up a signal.
That's the analogy, yeah. The idea is that consciousness itself is universal, perhaps non-local, existing independently of individual brains. Our brain just taps into this field. Now, obviously, this view leans towards ideas like panpsychism or even dualism, separating mind and brain. And a major criticism from the mainstream is that it's very difficult, maybe impossible, to test empirically in a traditional scientific way.
Right. How do you measure a field of consciousness?
Exactly. That's the challenge.
Okay, so Van Lommel uses NDEs to argue the brain is a receiver. And building on that kind of idea, there's Bruce Lipton. He takes this concept of consciousness as something external and really runs with it, doesn't he? With his analogy of the brain body as an Earth rover controlled by NASA.
He does. Lipton's model is quite distinct.
Yeah.
He paints this picture where our conscious identity, our self, actually exists outside the physical body, and it interacts with our brain and body through some kind of receiver interface, like remote controlling a vehicle.
It's a striking image. Makes you wonder who's holding the joystick, doesn't it?
Indeed. And he weaves this into his work on epigenetics. He argues passionately that our thoughts, our beliefs, which he views as forms of energy, directly influence our cellular function. They can switch genes on or off. So for Lipton, it's not just genetics dictating things. Consciousness actively drives our biology, shaping our genetic expression.
That's a reversal of the usual view.
A significant one, yes. And he extends this idea even further, talking about collective consciousness, even planetary consciousness. He uses the metaphor of humans being like individual protein cells forming the membrane of a larger organism, Earth, contributing to a shared global awareness.
Wow, that's expansive.
It is. He also makes a very clear distinction between the conscious mind and the subconscious mind. The conscious mind for him is the creative, goal-setting part.
Yes.
But the subconscious, that's the autopilot.
The autopilot.
Yeah, programmed mostly in early childhood, running maybe 95%, even up to 99% of our daily behaviors, thoughts, and reactions automatically. He argues that when our conscious mind wanders or isn't paying attention, the subconscious programming just takes over and runs the show based on those old tapes.
So a lot of our life is run by these subconscious programs, according to Lipton.
That's his view. Now, it's a really compelling narrative, and it resonates with many people, especially in wellness and self-help circles. But it's important to add the scientific caveats here. Lipton's blending of quantum physics concepts, consciousness, epigenetics, and biology. Well, it's often criticized by the mainstream scientific community.
For lacking proof.
For lacking rigorous, controlled empirical validation, yes. His analogies, like the broadcast receiver or the rover, are powerful metaphors, but critics argue they're speculative leaps, not grounded in established scientific evidence. So while his ideas are definitely thought-provoking and influential for many, they haven't really crossed the threshold into accepted, empirically supported science.
Okay, understood. So we have the brain-based theories constantly being tested and refined, and then this counter-narrative suggesting consciousness is external, often drawing on NDEs. NDEs seem like a real battleground here. If consciousness can exist without brain activity, they seem like the prime evidence. So, zooming out from specific cases, what does the broader clinical research actually show?
Well, the clinical findings on NDEs are actually quite nuanced and often debated. You have studies like the AWARE studies, led by Dr. Sam Parnia. They specifically tried to find verifiable evidence of out-of-body awareness during cardiac arrest, placing targets in rooms that could only be seen from above, for instance.
Did they find anything?
They found a small percentage, around 2% in the first AWARE study, reported experiences consistent with awareness, but only a couple of cases had potentially corroborable details, and even those were debated. The follow-up study, AWARE-2, gathered more data. Early reports suggested maybe 10–20% of cardiac arrest survivors reported some kind of NDE or reloaded memory.
Okay, so the experiences are relatively common.
They seem to be, yes. But here's the crucial part. There's currently no publicly available evidence from AWARE-2 showing any patient who reported a detailed NDE also had simultaneous EEG recordings captured during that specific time. In fact, for the patients where they did have EEG data during the resuscitation efforts, none of those individuals reported any conscious recollection from that period.
So the link between reported NDEs and documented flat EEG isn't there in that data.
Not in the publicly presented AWARE-2 data, no. So while the studies confirm these experiences happen, they haven't provided that clear, unambiguous evidence of consciousness persisting completely independently of any brain activity during clinical death. That claim remains, well, speculative based on current large-scale studies.
And what are the main criticisms from skeptics about NDEs in general?
Critics often point out methodological gaps. For instance, a flat-scalp EEG doesn't always guarantee zero activity in due to brain structures. They argue recall might depend on residual activity in brainstem or other areas, or perhaps the memories are formed or consolidated just before the heart stops or just after it restarts, when brain function is returning but still abnormal.
Okay, so there are physiological explanations, potentially.
Right, or pharmacological explanations related to drugs given during resuscitation, or psychological explanations involving expectation or memory reconstruction.
This really sets the stage for one of the most fascinating and frankly intensely debated cases in this whole field. The Pam Reynolds case. I mean, this story is just wild. Pam underwent incredibly complex brain surgery for an aneurysm. To do it, they lowered her core body temperature down to 10 degrees Celsius. That's 50 Fahrenheit. Her heart was stopped. Blood was drained from her brain.
Induced hypothermic circulatory arrest, a state of profound clinical death.
Exactly. And crucially, her EEG brainwaves were monitored and became completely flat, clinically dead by pretty much any standard definition you can use. Yet her testimony afterwards, documented meticulously by Dr. Michael Sabom, it's extraordinary. She described hearing a specific musical tone, like a natural D, pulling her out of her body. Floating above the operating room, seeing things with remarkable clarity, clearer than normal vision, she said.
And the specific details are key here.
Absolutely. She observed the surgical team using a particular bone saw. She described it looking like an electric toothbrush with different heads stored in a case that looked like a socket wrench set.
A very unusual description.
And one that was later confirmed by the surgical tools manufacturer. Even the surgeon apparently wasn't familiar with its appearance beforehand. She also reported overhearing a female voice say something like, "Her arteries are too small," referring to difficulties placing a catheter and needing to switch to use the vessels in her left leg instead of the right.
Which was also confirmed by the medical records.
Exactly. And just to add another layer, she recalled hearing the song Hotel California playing later in the procedure during the wound closure phase when she was being rewarmed. It's just a remarkable collection of details.
It really is. And the Pam Reynolds case becomes this focal point for the entire debate because of those verifiable details coinciding with documented flat EEG. Now, one of the strongest arguments against her simply hearing things normally is the setup they used. They had earplug-style speakers inserted deep into her ears.
Right, to block sound.
To block external sound, yes, but also to emit continuous loud clicks, like 95 to 100 decibels directly into her ear canals. This was to test her brainstem auditory evoked potentials, to monitor basic brainstem function. These were taped securely in place. The setup was specifically designed to make normal hearing of conversations or background music in the operating room highly, highly implausible.
So if she couldn't hear normally, how do skeptics explain her detailed account?
Skeptics raise several possibilities. One is anesthesia awareness combined with later reconstruction. Some anesthesiologists have suggested she might have had moments of consciousness during the procedure, perhaps before or after the period of deep hypothermia and flat EEG. Maybe she picked up fragments of information then or inferred details based on general medical knowledge, and her brain later stitched these together into a coherent narrative, possibly filling in gaps.
So memory playing tricks,
A
essentially.
memory construction, yeah. Psychologists also point out how memory can be fallible, especially under stress or unusual physiological states. Another point raised is the effect of the drugs used. She received high doses of barbiturates for neuroprotection during the cooling. These drugs can cause vivid hallucinations or dreamlike states, especially during altered states of consciousness, like induced hypothermia. So perhaps the experience was more like an extremely vivid, drug-induced dream structured around snippets of reality.
Okay, those are some significant counterarguments. Anesthesia awareness, reconstruction, drug effects. But given those really specific details, like the bone saw description, how plausible is it that all of that was just inferred or hallucinated?
That's the crux of the counterargument from her supporters, including Dr. Zabalm. They emphasize that the medical staff themselves were reportedly astonished by the accuracy of her account immediately afterwards. They apparently told her things like, "This wasn't a hallucination, this really happened," confirming the details she reported. The technologist who managed the auditory evoked potential system also reportedly insisted that external sounds simply could not have gotten through that sealed earplug system and that bone saw description. Getting that detail right, a detail unknown even to the lead surgeon, confirmed only later by the manufacturer. That's very hard to explain away easily as just inference or hallucination. For proponents, the sheer specificity and verifiability of details like the saw and the overheard conversation occurring during documented brain inactivity and with hearing blocked makes the Pam Reynolds case exceptionally strong evidence challenging purely brain-based explanations of consciousness.
So it really boils down to this. Critics emphasize the possibility of reconstruction, residual awareness outside the flat EEG window, or drug effects. Proponents highlight the uncanny accuracy of specific details that seem impossible for her to have known through normal means under those conditions.
Exactly. It encapsulates the whole debate perfectly. It remains one of the most compelling and contested NDE accounts out there.
Okay, wow. Let's shift gears pretty dramatically now. We've talked about the mystery in our own heads. If we can't even fully agree on how consciousness works in us, how close are we to actually building it? This brings us to the really cutting edge, maybe slightly sci-fi world of silicon and biological AI. What's happening with attempts to mimic the brain in hardware?
Yeah, this is a fascinating area. We're seeing huge strides in what are called neuromorphic chips. These aren't like your standard computer chips. They're designed from the ground up to emulate biological neurons.
Emulate how?
They try to mimic key features like neuronal spiking, sending signals only when the threshold is reached, and having memory located right where computation happens, more like synapses. They also often communicate asynchronously, meaning not locked to a central clock, which is more brain-like and energy efficient.
Interesting. Who are the main players in this space?
Well, there are several big ones. Intel has its Louis-He 2 chip, and they've built the Halo Point system, using it currently, the largest neuromorphic system, they say, with something like 1.15 billion artificial neurons. And it boasts incredible energy efficiency gains over traditional hardware for certain tasks. IBM has had projects like True North and its successor North Pole. There's BrainChip with its Akida chip, SynSense with its Dynest family, often focusing on low-power AI for edge devices like sensors or wearables.
So lots of activity. What's the core goal? Just speed or something more?
It's really about achieving brain-like efficiency and learning capabilities. The brain runs on ridiculously low power compared to supercomputers doing complex tasks. Neuromorphic chips aim to capture some of that efficiency by mimicking the brain's architecture. And there was a really neat breakthrough announced by the National University of Singapore recently. They showed that a standard type of silicon transistor, something called NSRAM, fabricated using common CMOS processes, can actually be made to emulate both neuron-like spiking and synapse-like memory storage.
Using standard manufacturing.
Yeah, potentially making these neuromorphic approaches much easier and cheaper to scale up in the future.
Okay, so silicon is getting closer to mimicking neuron behavior. But then there's something even more. Mind-bending. Hybrid systems. Biological neurons on chips. Tell us about Cortical Labs and Bit.bio.
Right. This is where it gets really wild. Cortical Labs, in collaboration with Bit.bio, developed something they call the CL1 biological computer.
Biological computer.
Yes, it integrates living biological neurons specifically, around 200,000 living human neurons derived from stem cells grown directly onto silicon microelectrode arrays. So you have biological brain cells interfacing with electronic circuitry.
200,000 human neurons on
Yeah.
a chip. And I read, it can learn. It learned to play Pong.
That's the truly surprising part, yes.
Yeah.
They demonstrated that this dish brain, as they sometimes call it, could learn to play a simplified version of the video game Pong. The neurons received feedback via electrical stimulation about the ball's position and paddle misses, and they learned to control the paddle via output signals from the neuron activity. It showed a form of basic goal-directed learning in a synthetic biological system.
That is astounding. Does this mean it's conscious?
Okay, that's the million-dollar question, isn't it?
Yeah.
But no, it's absolutely crucial to clarify. While it demonstrates a fascinating form of synthetic biological intelligence and learning, it is not considered conscious. Not even close. These systems are still very limited. They have issues with reliably transferring learned information. Their memory isn't very stable. And the lifespan is a major constraint. The neuron cultures typically only survive for a few months. So the main achievement is really showing that biological neurons integrated with silicon can exhibit adaptive learning behavior. It opens up amazing new avenues for studying learning, memory, effects of drugs, maybe even understanding brain disorders, but it's not sentient.
Okay, so pong-playing neuron layers aren't conscious. What about those advanced silicon neuromorphic chips then? With billions of artificial neurons like Hyla Point, how close are they to consciousness?
Well, let's break down what's been achieved versus the massive gap that remains. What we have achieved with digital neuromorphic chips is scale millions, even billions of artificial neurons on a chip. Incredible energy efficiency for specific tasks. They exhibit neuron-like spiking behavior, and they can perform on-chip learning for pattern recognition or control tasks. But the limitations are still huge when you compare them to a human brain. The number of connections or synapses per neuron is often far lower. The complexity of tasks they can handle and learn in real time is still relatively limited compared to biological plasticity. The human brain has around 86 to 100 billion neurons, each with thousands of connections. We're not near that scale or complexity yet. And the software ecosystems to actually program and utilize these chips effectively are still pretty immature. Scaling them up to achieve the kind of general-purpose intelligence we see in, say, large language models today is still highly speculative, let alone achieving subjective experience.
So mimicking the structure doesn't automatically give you the function, let alone the feeling.
Exactly. We're getting better at mimicking certain behaviors of neurons and networks, the spiking, the low power use. But creating genuine understanding, context, flexibility, and especially that inner subjective feeling,
Yeah.
that's a whole different ballgame. That's still firmly in the realm of biology as far as we know.
And what about timelines? When might we see these advanced chips actually being used widely? And the C word, consciousness.
For the chips themselves, some estimates suggest maybe 5 to 10 years before we see production-ready, large-scale neuromorphic processors becoming commercially viable for specific AI applications where efficiency is key. But for true consciousness in silicon or even these biological hybrids, honestly, most serious researchers would say we're talking decades away, at the very least, if it's even possible. We face fundamental roadblocks. Things like the limited lifespan of neuron cultures, the challenge of creating persistent, transferable memory in these hybrid systems, massive scaling issues, and of course, profound ethical considerations.
Right, the ethics alone are staggering.
Immense.
So, okay, to sort of wrap up the section on building brains, we're getting incredibly good at mimicking the mechanics of neurons electronically, achieving amazing power efficiency, but replicating the sheer complexity, the dynamic plasticity, and most importantly, those elusive subjective qualities of biological consciousness. That seems like it's still far, far beyond our current grasp in silicon or even in a dish.
That sums it up very well. We can copy the notes maybe, but we're nowhere near replicating the music.
What an incredible journey we've taken today. Just trying to get our heads around, well, our heads. We've covered so much ground reviewing these major perspectives on consciousness. We started with the brain-generated view, right? Looking at those key theories like IIT and GWT.
And the new findings pointing toward the posterior cortex maybe being more central than we thought.
Exactly. Then we pivoted to that completely different perspective, the counter-narrative suggesting consciousness might be non-local, external. We heard about Pim van Lommel's NDE research.
And Bruce Lipton's ideas about the brain as a receiver and consciousness shaping biology.
Right. And woven through that, these compelling but still fiercely debated near-death experience accounts, especially that really striking Pam Reynolds case.
which highlights the core challenge so vividly.
And finally, we looked at the future, the efforts to build consciousness, or at least intelligence, in neuromorphic chips and even using living neurons.
Yeah, showing both the amazing progress in mimicking brain mechanics and the vast gulf still remaining before we get anywhere near artificial consciousness.
What seems really clear listening to all this is that despite all the progress, that fundamental hard problem you mentioned at the start,
How physical stuff gives rise to subjective feeling.
yeah, that remains profoundly unsolved. It doesn't matter if we're mapping brain networks with incredible detail or building billion neuron chips. That core mystery persists.
It absolutely does. It's the central enigma.
But what's so fascinating, I think, is how each of these different perspectives, neuroscience, NDE research, AI development, they all push the boundaries of our understanding in different ways. It just shows how much more there is to learn about ourselves, about the nature of reality itself. It's humbling, really.
It is, and it forces us to confront some truly deep questions. If consciousness isn't solely confined to the physical brain, and that's still a big if, scientifically, what are the implications? How does that change our understanding of life, death, identity? What about the potential for future non-biological intelligence if consciousness isn't tied strictly to biology? It really brings it back to a very personal, provocative thought for everyone listening. What does it truly mean for you to be conscious?
A perfect question to end on. We really hope this deep dive has given you plenty to think about and maybe sparked your own curiosity to continue exploring these profound questions.